Lesson 7-1, multiplication properties of exponents. Our objective with this lesson is to multiply monomials using properties of exponents and also simplifying expressions using the multiplication properties of exponents. So the standards that we're covering are Algebra 1, 6-2, 6-3, and also 9-8. So you have been given this definition of a monomial before, back in pre-algebra. This is kind of a pre-algebra thing, knowing what a monomial is. A monomial is a number, a variable, or a product of them. And some examples of monomials are just the number 5. That's a monomial. Mono means one. So it's just one number, variable, or product. There's no pluses or minuses between them. Okay? That's the key. There's no pluses or minuses between them, and there's some things that eliminate things from being monomials. But again, examples of monomials: 5, just the variable x by itself, but also if it was x squared or x cubed, because it's just a product of variables when you have x squared or x cubed. Definitely 7ab, it is a combination or product of a number and two variables there. And then I want you to see that y over 3 would be a monomial because that is really 1/3 times y. Okay, which makes it a product. So here's the things that eliminate things from being monomials, and therefore they're not a polynomial or any kind of nomial. They're just nothing. I shouldn't say it that way, because the first one, now that I see that, it is not a monomial, but it is a polynomial. B plus 2. Okay, since there's a plus sign in between, that really isn't a monomial. There's mono means one, so a polynomial that would have two parts would really be a binomial. Bi means 2, tri means 3. So 10 minus r, well, there's a minus sign, so it's not a monomial, but that one has two parts. It would be a binomial. The two things that eliminate from being any kind of polynomial at all would be a division by a variable, 3 over y. Can't have y on the bottom. You can't divide by a variable. That is not a monomial or any kind of polynomial. And then a square root of a variable, that eliminates it also. Square root of x keeps it from being any kind of polynomial. So here's what we're going to do. We look at some problems to make sure you know that it's a monomial or not, whether it is or not, and why or why not. And the explanation is probably just as important as knowing why or why not. So if I look at these, 17 minus x, do you think that is a monomial? No, we just kind of said no, so you would definitely say no, and the reason is it has subtraction. The only thing that is allowed with these is multiplication. So since it has a subtraction, it really isn't a monomial. Okay, what about 8f squared g? Who thinks they know this one? Yep, Ben.
Yes.
Yes, because it is a product. It's a product of numbers and variables. Okay, 3 3/4. 3/4. Kind of hard to read that. What do you think? You think that is a monomial or not, Josh?
Yes.
Yes. Why?
It's a fraction.
Because it's a, what's the part that's allowed? What do we say that? Look at the definition. It is a very first word in the definition. It's a number. Okay, and then 9x over y. Monomial or not? My tree? No, why?
Because it's being divided by a variable.
Right. Division by a variable. Division by a variable is not allowed. Okay, so be able to identify if something is a monomial or not and say why or why not. The only thing that basically is allowed is multiplication, products of numbers and variables. If it's just a plain number, it's good. If it's just a plain variable, it's good, or a product. All right, now we're going to move on talking about different things that can happen with monomials. And we're talking about something called product of powers. Okay, and product of powers is you take something with the same base. So maybe we better go back and do this. Let me write this over here by the side of product of powers. Let me go 4 to the 5th. Okay, 4 to the 5th power. This 4 is known as the base. It's the base unit, 4. And then 5 is known as the exponent or power. And that number tells you how many times you're going to take that base and multiply it by itself. So base is what's written there, the 4, and it's to the 5th power, or the exponent of 5. All right, now I'm ready to go on. A to the 5th times a to the 3rd. So it says, with an asterisk here, means that it's pretty important. When multiplying the same base, in this case a and a, when multiplying the same base, you add the exponents. So a to the 5th, I've really got that right here, don't I? That's really a to the 5th. I've written out a 5 times. It's all a multiplication. And then this one is a to the 3rd, but you don't have to write all that out when you're actually doing it. You just say, my base is going to remain the same. It's an a, and it's to the 8th power. Now, if the bases aren't the same, there's a couple things that happen. If they are numbers, you multiply those numbers out like normal because it's a multiplication problem. If they're different letters, you just write the different letters and only combine them with the ones of the same base. Or you just kind of bring them along if there's only one of them. It's just still a multiplication problem. Just keep that in mind. It's still a multiplication problem. And when you write letters side by side, it's automatically multiplication. Okay, so let me kind of scroll down here a little bit so we can see all of these examples. I guess we just have those two. So I would have to take k to the 4th times negative 12 k to the 7th. Okay, what number's in front of k to the 4th, Jared? Okay, which means it's automatically a? The number in front of k to the 4th is automatically a 1. You knew that. 1 times negative 12, because they're not the same base, would be negative 12. But, Jared, what about k to the 4th and k to the 7th? Right, which would be k to the 11th. So negative 12, k to the 11th is what you'd write. All right, example F. 3xy squared times negative 2x squared y cubed. So you start with the coefficients in front. They're not the same base, so you'd have to take 3 times negative 2, negative 6, and then you start with the same bases. So I've got an x in the first monomial and an x squared in the second. What would that be when I multiply those together? Avery?
X to the 3rd.
Yeah, x to the 3rd. Because even though it's not written there, this has a 1. Okay, then you move on to the y's. The y's are the same base. There's 1 to the 2nd power and 1 to the 3rd power. So a total of y to the 5th power. So your final answer, negative 6x cubed y to the 5th. Okay, questions about that? Ben? Okay. All right, let's go ahead here. Now we're going to talk about something called power of a power. Power of a power means that you have something like a base of a. It's already to the 5th power, and that whole thing's taken to a power. So pretty much anything that would be inside these parentheses have to be taken to the 3rd. Well, that means I would have a to the 5th times a to the 5th times a to the 5th, and if I added those 3 5s, it'd be 15. But you know what? You don't have to write all that out. When you have a power on a power, you're just multiplying the exponents because it just means you have that, what's inside the parentheses, that many times. Just make sure that you apply it to everything inside the parentheses. Even if there's coefficients, they have to be taken to that power. So let's look at a couple of examples. Example G, it says x squared y cubed, and it's all taken to the 4th power. So if I start with my x, it's already squared, but it's taken to the 4th power. So x is really going to be to what power? 8. Y starts out to the 3rd, but it's really being taken to the 4th power. So what is it, Olivia? 12. So you'd say x to the 8th, y to the 12th. Again, if there was a number in front, you would have to take that number to the 4th power. Don't leave it to that. So let's just say, for example, let me go ahead and do this. Let's say it was 2x squared and we took it to the 4th power. You really would have to take 2 times 2 times 2 times 2. What is that? 16. Don't leave it 2 to the 4th power. Numbers you go ahead and multiply out, okay? And then x to the 8th. All right, just want to clarify that. The next one, that looks really interesting. Look at that. 2 cubed, squared. Goodness gracious, that's a lot. What's it going to be, Ethan? 2 to the... Two to the 18th. Okay. There you go. 2 to the 18th. Now, that is an excellent question. So here's the thing. When there's only numbers involved, it's kind of an unwritten rule, you can leave it 2 to the 18th. But when it's combined with variables, you really want to go ahead and multiply it out. I will tell you the truth, if you went ahead and applied 2 to the 18th and gave me the full answer, it would not be wrong. Okay? You could do that. That's not a problem. Either way. Huh? Oh, no. You would have to leave your base 2 to the 18th. And then you could use a calculator and take 2 to the 18th power. I wouldn't recommend multiplying that all out. It's huge. 262,000 with some other... 144. Okay, so if you multiplied that out, that definitely would not be wrong. But I will tell you, as we're grading, if it's just numbers, you may leave it to an exponent, and that's generally how we look at it. It's when you have numbers combined with variables, you shouldn't leave those to exponents. Okay, that's just kind of how we do it. All right, I'm going to have to stop this, and we'll pick up here in just a minute.